bulbs. Did you hear that? So our little engineers are claiming LED bulbs are one of the most special kind of bulbs, and they can change colors. It's absolutely
Like I used to have an LED thing like that could turn blue colors.
right.
And
LED
the
can,
same thing too.
right, and LED can do that. So I think eventually we'll give it to Uncle, and I am so much excited to hear about how LED bulb works. Are you guys ready?
Yes, and we'll see the problem. And what's going on?
I think not the bulb is we're gonna learn the bulb today. So
LED
another thing.
bulbs.
So we're not doing a repair project today, by the way, team. So before we start, just a precautionary tale. Today we are playing with a light bulb, which is an LED light bulb. It's not a normal light bulb, and it has some glass, some plastic, like some element which are extremely dangerous.
So be cautious.
Be very cautious. So always wear safety gears and always maintain a safety distance.
And did you
And if you don't know what's going on, consult a professional. Look around the safety manual. Make sure you know what you're doing. But at the end of the day, there will be a lot of learning. We little engineers want to know what's going on inside these light bulbs. So Uncle, take it away.
Leah, you have a question?
No, I just wanted to say something. Wait, I forgot.
Okay, no worries. You can come back afterwards.
Okay.
All right. Before we jump into the LED bulbs, I'll give you some high level how bulbs work. Okay, and then we'll jump into the LED bulb. Does anybody know how a normal bulb works without the LED?
Yes, Mia.
It is kind of oh wait, sorry.
Mm-hmm.
It's round and then thin at the bottom,
Mm-hmm.
but it has a spring. What is that for? I know. That's to twist it into something, and the electricity.
Mm-hmm.
There are electricity things everywhere, and then the electricity goes in the bulb,
Mm-hmm.
and then it goes through it just goes through some wires, and then one of the wires makes the electricity go into a bulb.
Okay.
And then
That's a good point.
that little bulb is inside the real bulb.
Mm-hmm.
And then it just makes this go very bright.
Ah, so we have a bulb inside a bulb. It's like a Russian dolls. Like a doll inside a doll. Ishida, do you want to guess? Mia, by the way, very good on that. Ishida.
There are two little boxes of positive and negative charges.
Mm-hmm. And
And would. Okay, I don't know how to explain it.
That's fine. Buddy, you want to try?
Yeah.
Good job, Ishida.
This is mine, and that's Ishida's.
Inside a little tiny wire, and then it leads it to the light bulb inside, like and the bulb inside the bulb. It goes
That's
to
a beautiful point.
And then it throws it out, and then it goes.
Do you know what that tiny wire is made out of? It's a special material.
I know.
Yes.
Tinfoil or metal.
Tin foil.
or copper?
Gold.
Yeah.
Copper.
Yeah.
All right. So guys, pay attention.
Bronze.
All right.
Silver.
Leah,
That's fine.
team, let's pay attention. So I'll show you the difference between a normal bulb and an LED bulb. Okay. So a normal bulb, you guys know there's a battery or energy source, right? Sometimes where the electricity comes from, right? And then all it is, it goes into something what we call a resistance. Resistance. Remember, if you guys remember,
Our old friend.
remember talk about resistance. We were like, oh, if you want to go straight, but there's incline, if you can't go straight away running. It's like when you put a bucket.
No, slow down.
Exactly.
You just don't want to go super fast and get the bucket on top of your head.
Yes.
You go slowly and you put it in a cup.
And it gets heated. It gets heated because it's so tiring.
Yeah.
It gets heated.
So think of resistance when you are going on a road. Remember that speed bump kind of thing?
And the little yellow light, the yellow light is a resistor and it says,
But when we come in, we just have to.
Yes.
Yes. Buddy, you remember the
the
example?
yellow light is like for slow down.
Yeah. So whenever you want to slow down, something is going fast, when you want to slow down, it produces heat. So let's remember Pari's example. If you are going on a road like this and you're trying to go up, trying to run, you get warm, right? Right? When you're going trying to when you're running on a straight road, it's okay, you're running. But if it goes like this and you're like trying to run really fast, and then you get tired and your body gets hot, right? So when your body gets hot, it emits this energy, which is converted into light, right? And that's how a normal bulb works. So the electricity comes really fast, the resistance slows it down, and in the process it heats up and then emits the light. Go ahead, Ishita, you have a question?
I noticed that there's a little positive and negative.
Yes. So we created the battery. So see, this is the voltage difference. There's a positive and a negative, and that's why in the normal.
So this carries the positive charges and this carries
Negative charge. Yes. Electrons flow like this, and the current flows like this. Okay, in the circuit. So this is the normal bulb, right? But the bulb that we are looking is a special bulb. What is it called? Anybody remember?
LED light.
Yes. So LED. The LED stands for light emitting diode. What does it stand for?
Was in a circuit thing.
Yes, Mia, good catch. So we will talk about this diode. Yes.
So you guys have seen a diode. Remember I showed you, we opened up a circuit and you had something like this that looked like this.
I have a question.
Remember?
I have a question.
That's
So
a diode.
for Ankur uncle, if we already have a bulb that we think it works, right? Why do we need LED bulb?
That's a very good question. So let's try to answer the question, okay? So what happens is, when we are putting, Mia, you want to guess?
I know.
What?
So the bulb can give you light that can be different colors.
That's good. That's
a
one
very good
benefit.
example,
That's one benefit.
Thank you.
But there is also very important benefit. The other benefit that we have is this old way of putting a bulb. We marrying a positive charge to a negative charge just through this resistance. So there's a loss of when you get tired. You know when you this energy comes out when you're running up the hill. You get tired very quickly, right? You can't run up the hill all the time, every time, right? If I tell you keep on running up the hill every time, you'll be tired, right? So that's what happens on normal bulbs. It wastes a lot of energy. A lot of energy goes this way, and then it gets converted into heat, and heat comes out. The bulb gets really warm, and it wastes a lot of energy.
I know that's why it's super high, so we can't touch it.
So tell me, my little engineers team, if I give you say 100 donuts to eat, and you just get one, will you be happy? No, right? Because you want as many donuts as possible, right? That's what happens here. So you send this bulb 100 donuts, only one donut is being eaten, and 99 donuts just get wasted.
Yeah.
So there's a lot of wasting going on, and you would love to eat that donut.
So Uncle Vishal give you a very good example, because only small part of the energy is converted into light, and a lot of energy we lose in terms of heat and everything else in the circuit. So see, all these red arrows are the energy we are wasting, and the blue ones are the only ones that you're getting out of from in terms of light.
More energy for the LEDs.
No, so this is what the benefit of the LED is. I'll show you. LED actually uses very less energy compared to the old bulb. So the way a LED bulb works, now let me go to the basic principle and then we'll try to open the bulb and see, okay? Okay, so the basic,
I know.
okay,
Those are amazing guys, by the way.
yes,
Kudos to
all the
what's the school
principals.
name?
Principal, my principal's name is Dr. Seidel.
Shout out to Dr. Saida.
Mr.
Lakava.
Mr. Lakava, shout out to you.
And mine says Miss Langel.
Mr. Langel. So
Shout out to all the
all the
principals.
three principals. Amazing job, by the way. You are producing such a beautiful and amazing little engineers for this world. Thank you so much.
Alright, so now this is how, now pay very close attention. This is how a light emitting diode works. So see, you have the same battery, right? It's sending the current. First we use a small amount of resistor to slow it down a little bit. But this is the important part. There are these positive ions and there are these negative ions. And when the voltage difference exists between this and this because of the battery, what happens is that one negative charge and one positive charge, they meet, and they put in the process of meeting, they emit Light.
So guys, do you remember when say you have two friends, right?
Wait, I
So Mia,
Mia,
you
remember?
have light?
yes. So basically,
It's all light bulb?
if you have two friends, right, you're coming to each other, right, very fast. So you guys are running to each other, and suddenly you guys banged, right? Then there's a noise. You hear someone just crashing into one other guy, right? So that means what's happening then is it's discharge of energy. So a lot of energy sort of goes out in a form of noise or voice. In case of here, the both two friends are running to each other, they're fighting, and then the energy is discharged in a form of light.
Like what happened in school.
Yeah, you bumped into each other and bumped your head, and there was a huge noise. I was like, what's going
What
on?
happened in my school? Me and Shristi were running.
Yeah.
We had to hug each other, but we should just instead we just.
That's what happens here all the time.
We have to go to the school nurse.
Yeah.
Yeah. So now watch this.
Look at this. Look at this.
Now watch this very careful. So these are your negative electrons. These are your positive holes. And what happens is they try to like Pari was saying, they both run towards each other, and what happens? You see the positive hole, the negative electron gets into the positive hole, and then in the process they emit light.
It's a bang. So this is like that.
Can you draw a light bulb or a bright light?
Yeah, and they emit light. And usually, we won't talk about this in future, but they emit light in the process.
Bright light?
I love it. Our uncle is like amazing coach. So he has already given us a glance of the future. So
Alright, so we basically when this negative, so you guys understood, right? When these are positive holes and there's this, and electricity is pushing the electrons and saying, okay, go towards each other. They run towards each other and they meet like this, and then in the process we emit some light in the form of energy in the form of
When it
light.
makes a noise, for us, we like so it makes a noise.
And I
But
think-
this one makes forward the
and,
light.
and team, I think one of the interesting thing to capture is or to notice here is, so if you have two mugs of water, right? One mug has half filled water, and the other mug is completely full. If these mugs bang into each other, what happens? The filler, the mug which is full, which is a glass full, will spread water all over the place, right? So that's what happened. So these negatives, so these are like big glasses with filled with complete water. So they're very high energy levels. And these are okay, I can talk to you, like very sort of half-filled glasses. And when, as Uncle beautifully said, the moment they hit it, we see spill over. This guy, and that thing turns into light.
Like it's like you're screaming.
And you know what is the beautiful thing here? Now, out of 100 donuts, you get about 16 to 17 donuts to eat.
Yeah.
Imagine last time you were just getting one, now you got 16 to 17 donuts to eat.
Now
We all want to eat 100 donuts, by the way. I don't mind getting all the 100 donuts that we can eat, but we're not there. We do roasted orange donuts. By the way, that's true. That's true.
Alright guys, one more thing, one last thing. So let's try to answer what Mia said. Mia, you remember you said one other benefit of light emitting diodes is that you get different colors of electricity. Remember? So what happens is all these positive the positive holes that we talked about. Mia, can you please pay attention? Okay, all these positive holes and these negatives, they are at what we call different spectrum or different wavelength of light. Okay, and when they meet, when the top ones meet, they produce blue. When the bottom ones meet, they produce red, and all the colors in between. So it depends upon which spectrum they meet, they produce different kind of light.
Wait, I had a blue one with the top mist.
Yeah.
So it just turned blue.
And I think, and you can think of this way: if you have glass completely full, there'll be a lot of splash.
Yes.
If the glass is slightly less full, you still get a splash, but still get splash. So based on how much splash you want to get, if you change the glass size, that's why we see multiple colors. Because in that, we can now have 3 glasses hitting with a small glass, and every time the glass hits one of these guys, we'll get that color.
Or I'll give you one more example. You have any question?
Oh, what does metro mean?
So
What mean? Leah, wait for her question, please.
Electron.
Electron.
Very good question.
So electron is a negative charge, and
Negative and the positive.
yes, electron is the negative charge, and we had the positive hole. So now keep this. This is how what we were talking about different. So see, let's say this is the positive hole, and this is electron, and if we do like this, see, it was.
You heard the clap, right?
Right. It's a different clap, right? But if I go really fast, you heard a louder clap.
That's a blue light. That's a red light.
So see, so if you clap like a really small, this is a red light. If you go, this is a blue light, high energy, low energy. Yeah.
Uncle, amazing. I think this is the best explanation I've ever heard about diodes anywhere in the world. That proves our little engineer club team is the best team in the whole wide world. Yes, Ishita.
I just said light emitting diode too.
Yes.
Alright.
And by the way, we also call it light emitting device. Because
Light emitting device.
Leah, you have a question?
Yes,
Yes, you have a
I
question?
wanted to tell something.
But do you have a question?
No.
No, then we'll come back to you afterwards, okay?
Oh.
Alright, so now it's the practical time. Now we understand the theory. You guys understand the theory?
There's a magnet.
Where's the
So,
magnet?
I think before we go on this section, I think a cautionary tale. So now we are going to open this bulb.
Yes, pay attention.
And the entire team, I want us to pay very close attention. It's a safety measure, so it's a safety caution. We have the siren on. So this time we are trying to open the bulb, and you look, there may be glasses, and if the glass shatter, it spurts and it could hurt us. So we have all the safety gears to protect us, and uncle have safety sort of gloves to maintain that. So we're gonna take a try. Again, it's a very safety hazard. Unless you have the right tool, right safety equipment, right safety measures, this is not a step to pursue. And if you all have the safety measure and you know exactly what you're doing and being very, very safe,
And with an adult.
and with an adult, and I think that's the mandatory for all of our projects. You need to have an adult working with this project. So Uncle will take it away. Mia, yes.
And if he shatters, then we can. My dad, he has gloves on, so he can do this, so it won't shatter.
So I think as a precaution, all of our hands should be at the back. We're not touching.
I'm gonna put them
We
on
should
my
not.
bottom so I don't do anything.
Whichever, whatever. Just keep the hands away from the table. And now we'll try to see if we can open this bulb without shattering it. Otherwise, we'll shatter it somewhere else. So we don't get the spark glass.
Okay, we won't shatter it. We'll try to open it so you guys won't get shatters. Okay. So now before we open up the bulb, I want you to see what's outside the bulb. Okay. So outside the bulb, there are three components of the bulb I want to pay attention to. So one is this casing that where the light comes.
Plastic case for
protection.
Yes,
And
there
it
you
could be
go.
glass too.
Yeah, it could be plastic or glass depending upon this is where the light comes out from. And this is where usually the mechanism is, see the middle portion. And then there's the bottom portion where we actually feed the electricity. No, it's not a magnet, Leah, it's where we feed the electricity. So there are two terminals. There's this terminal and there's this. You know how we're positive and the negative?
That is a metal. That looks like a metal.
Yeah, it does. So now we'll try to open it, okay?
Actually, magnets attract metal. I just remember that.
Yeah, it's not gonna be.
Magnets do attract metal. No. I know, they always attract metal.
So I think yes, it turns out to be very nicely glued or fused
Super strong.
shell.
So you just pull
Yep.
something.
So we're gonna have to just shatter it somewhere.
I don't know this one.
And again, I think little engineers and everyone watching, one thing to point out here is again, we have tried opening the shell and we're not seeing it open easily. So we have taken it to a safe place so that it doesn't hurt us, and we can safely open this thing so we can bring it back and see what's going on inside these things. And our resident engineer Uncle has some of the best equipments to handle the situation. So I think that's one of the
I know
most.
nature वाला खो जाएगा, but then it's gonna destroy the circuit.
No, I think just if you can maybe cut the. Okay, this is good.
No, but I
So we have
the
yeah.
rest of it.
So the bottom came off. So
But the top didn't. The middle and the top didn't.
So this is amazing. I love
I
it.
want to see the bottom.
Hands back.
Okay, hold on. I'm gonna go get it in a vice.
Yes.
And this is the thing
Yeah,
that feeds the electricity and my connector.
So again, we at Little Engineers Club Lab take everything safety to the highest measure. So we are not able to open something, so we have taken it to a very secure lab. It's a very secret, secure lab. Where we
I know
can-
a secret lab.
Yes.
I know
And-
two secret labs.
Because it's our lab, so we know where sort of we can do all these breaking things stuff.
Three secret labs.
Yes.
One is in my
So
school.
again, use every
One
caution
is
in the
at
world
house.
to make sure don't hurt yourself.
Three
Okay?
labs I know.
It's very important for us to sort of Mia, girls. I think team. We have. Can you give me a minute?
You have to be
Yes. So be very careful again. It's I think we have to cut the glass open, or the shell. So we do it at a place where the shattered glass doesn't hurt, because it can go in your eye. It can cause a bruise. So be very cautious.
I got a glass in here on my
So team, I have a question for all of you. Team. So what do you think about the bulb so far? Do you know how it works? Do you know? So do we know why we use LED bulb and not the normal bulb?
Why?
Because we get less donuts. Remember? So we got 100. We just get one. I want to eat more. And the other thing is what Mia said. I want a blue light. Now I don't want another bulb.
All right, guys.
So what's the secret sauce, Uncle? What gets this?
All right. So let's go back to our parts. So if you guys remember, I told you there are three parts, right? So there's the bottom part. Everybody can see the bottom part. All
And top. I see this little circle board.
yeah. So the thing the bottom part does, if you guys can see, here you pointed out there's a things you were saying this is a magnet. It's not a magnet. It's just separating the charge. So see, this is one terminal and the other one is the center terminal. And if you see inside, what it does is it touches two different wires. The black wire, the steel part, the outside part, this part was touching the black wire, and the center part was touching the red wire, right? So it was feeding the electricity to the black and the red wire. You see that? So this was the positive and the negative.
This tiny circuit board.
Yeah, and then see, if we open up the casing here on the top, if you see, this is just empty. You guys see it?
That means it's just a cover.
Yeah, it's just a cover. There you go, buddy. Very good. So this is the core part of the mechanism. So if you see here, this is where it gets interesting. These things, anybody wants to take a guess what these things are? Does it say anything? What are those?
Can I see?
Yeah, you guys can see. One by one you can see.
Wait, I saw one.
No, no
that's the
touching,
word.
please. No
I
touching.
saw one
I
that's the
can't
other
see
word.
it that. Oh yeah, I see. I see it says 20, 30, 10, 10.
Maybe that's its voltage.
Do you see anything it says?
Maybe it's just voltage.
I know it says 40, 30, 20.
So if you guys pay close attention,
See everyone.
that's okay, no
It's
worries.
fine, it's fine.
I'll explain it here. So if you guys see, this one says D1, D2, D3, D4, D5, and D6.
What is D?
What does D stand for? Anybody wants to take a guess?
In LED.
Determination.
That's a very good Sean.
Determination, yes.
Diode.
Yeah.
Guys, you guys are amazing.
So this is the diode. So these are the diodes, okay? And if you've seen this previously in the circuit, and you have seen these things, so we'll try to decipher what this is. Anybody wants to guess what this is?
The brain.
Yeah, you remember that? Yeah.
I knew that.
Our team already knew this. I think it's amazing. Good job,
The
guys.
black. It's just something that is small, and it's black.
And it has a lot of legs.
No, it's just something small and black, and it's inside a circuit. Then it has to be the brain of the circuit.
Yes.
If it looks like that integrated circuit, then usually it's like that.
Or maybe it's one of the brains. Maybe it has multiple brains.
It can have a lot of brains.
It can have a lot of brains.
It can have 10.
It can have 20. It can
I
have
have
5.
100.
It can have 1.
It can have 22 and a million thousand.
That's
Yeah.
so many brains. I wish I had that many brains.
You have so smart.
I know. We can do so much fun stuff with
Alright
it.
guys, now pay attention. We're gonna try to see what's underneath this circuit, okay?
Oh my god.
Alright, yeah, that's interesting.
I always
Alright,
say that.
let's see.
That's my fashion word.
That's your fashion word.
Yes, I always say.
Our little engineers has fashion words too, by the way. So
Oh, here
they
we
know
go.
what-
So,
Yes,
alright guys, now pay attention. So, this is the circuit. If you see, it was plugged in here. You see that?
Can I see?
Vishal, can I borrow that? So, see, it was plugged into this circuit using. This is. Anybody want to guess what this is called? We've used this in the past. What is it called, Pari?
Is it called a resistor?
it starts with C.
Mia, you want to guess?
Can I see?
Anybody in the team wants to guess what it is? Yes, go for it. No, no. What is it called?
Caleb,
No.
kick.
No, top.
Does it look like a board?
Yeah.
Yes.
Good job, team.
Good job, team. Good job, team.
Start with the S.
C. It's a C. C with a circuit board.
Yeah. No, it's with an I and C and I makes it a circle. Yeah. It starts with it's sounding like a S, but it's just okay. We're not talking about letters right now.
Not like letters.
Guys are amazing.
It's a little bit of school.
Yeah.
So it's a circuit board.
I see it.
And in the circuit board, we've already talked about the main parts of the circuit board. So you guys talked about the brain, you talked about the diode, and then these are the terminals. Now these terminals will explain. Yeah, that could be a resistor. You're right. Oh, actually, that looks like more like a relay, but we'll talk about it.
Uncle,
Mhm.
I have a question. I put you in a black shirt and now you're in a blue
Can I see?
Now, what do we hear?
That's a
What?
very difficult problem. I agree.
Maybe he just changed his shoes.
I think so. I think so.
All right, here we go. Now, pay attention here, please. Oh, look.
I see a little circuit board.
So this is just empty right here.
What?
Yeah. And you see another
And
thing.
it's a magnet. It's a strong magnet.
I said that before.
That's good. The team said it.
I know
That's
what that is.
Team said
I know what that.
there you
I know
go.
what this is.
Yes. What is it?
I forgot what it's called.
Okay.
It's
Good.
not to the O.
Oh, that's a capacitor.
Yes.
Oh, yes, capacitor.
That's a
It's a
capacitor.
different kind of capacitor, I guess.
Yep.
Oh my god.
And
I never thought that.
and anybody want to get what this is?
Resistor.
Yes.
Nice.
And
Referring.
anybody want to get this?
I'm gonna hold.
I think it's a relay.
It's a, yeah.
This could be another capacitor.
Can I see the relay?
Yeah.
Where's the relay? Oh, I just saw the resistor.
Yeah. Resistor, relay, capacitor, another one. And then there's a circuit board underneath. Wow.
We have seen so many circuit boards by now. I think it's amazing how circuit board can do, right? What circuit board can do.
But why does everything need a circuit board?
I think that's a beautiful.
That's a very good
That's a
question.
very good question.
So why do you think it needs a circuit board?
To function properly?
Yes, and it also has to convert. See, remember we were talking about this diagram earlier. What we did not explain to you is we explained this is a direct current circuit, but
It's a battery.
It's a battery.
Hey, I read about the circuit.
Yeah, but when it comes in, it comes in as alternating current. So what the circuit first does, what the circuit first does is it converts alternating current to direct current. And then it also does this whole mechanism that we talked. It tells everyone, okay, it's now your turn to jump and collide. And then it tells the next one, your turn to jump. It controls the circuit.
And team, I have a
So that everybody doesn't run together at one time, right?
I have a secret to tell you. Don't tell it to anyone. It's a secret.
Oh,
The,
keep it.
the electricity that we get at our home, it's not the same as what battery has.
But we put batteries in our circuit things.
Yeah.
I like
You
a
know?
nice snap circuit.
So,
Yeah,
so
it's not-
whatever battery you see, as Uncle said, it's a direct current. It goes from positive to negative. But the electricity that we get at home,
Is alternating?
it's alternating. Our engineers are amazing. It's an alternating current.
Oh, I know.
Now the problem is LED can only work with batteries. When LED works with batteries, how can we light this bulb with this home electricity? We have to convert this alternating current, which is special light electricity that we get at home, to something direct current, which is the battery that we get to charge this thing. And that magic is done by that circuit.
So now let's recap. and see if you guys can. Then I'll ask you guys if you can explain how LED bulb works. Okay. So now what's happening is electricity is coming in from here at the bottom.
Sorry.
This is the, if we saw, this is the black part, this is the red part. It comes in from here. It gets into these wires, right? From the wires, it gets into this circuit. Pay attention, please. It gets it into the circuit, and through the relay and the capacitors and the resistors, it gets converted. And then from that, it gets into this real part, which is the diode part circuit board. And then these are connected here,
Wait, I didn't.
like that, right?
Oh yeah.
So it goes from the circuit board into this, and then it tells these diodes to switch on so that they can emit the electricity. And you also know how they convert electricity. We talked to you about this, right? Two people running towards each other.
Like in night school.
Yeah.
Me and Susie were running to hug each other, but instead we just crashed and I had to go to the nurse with my friends.
And
Okay.
I think
Those
one
two
thing.
stuff.
So I want to try something. Can I try something?
Yes.
Do I have the permission of my Electrical Engineers Club? Okay. So now we know. So this is what we'll see. What AC? So we know that the house electricity we convert it into battery. How do we do that? Do you want to see that magic?
Can I just tell something?
Yes.
Also, AC stands for alternating current.
Yes. So now this is how it looks, and it will blow your mind what's going on. So this is so typical battery current is like this. It's just straight. It's say whatever. So whatever volt you want to see, it's just this. This is 0, right?
Yep, positive and negative.
And when you see what's going on in our house, it's a special thing. See what happens here. It's a magic. Don't tell it to anyone. It's our close secret. Okay. Very few of us know what's going on. So this is. It goes like this. Isn't it funky? This is 5 volt. This is minus 5 volt. Now think how we can make something like this, Yes, little
My
engineers.
hands to make it like.
That's a very good point. I think that's a very good point.
Yeah.
So we have to do it by hands. So we have to do some magic, and I'll tell you a secret.
I know.
Careful. I think we have to be very careful with this.
Oh no.
So listen. So now what happens? Team.
Team, pay attention, please.
So now what happens? Mia,
Pay attention, please.
so now imagine what if I tip this over. So if I just do a magic and somehow as soon as someone goes here, I say, hey, don't go here. Can you just go here? And as soon as someone goes here, I say, don't go here. Can you go here? Do you see now what happened?
Yeah.
So we have almost like this, which is almost same as this guy, right?
You know who does this?
No.
A hand.
But in the circuit, our hands are not in the circuit. Anyone
That's
wants to
what
say?
this guy is all about. It's doing all this magic.
Yeah. So relay is the one that switches things.
Relay, rectifier.
Wait.
Yeah.
Is the really that like little red box?
Yes.
Yeah, relay is like a gate. It goes like, okay, if somebody wants to go this way, they say go this way.
That's Ankur, that's a beautiful point. So what it's the moment this comes here, the relay says, hey, don't go here, go here.
Yeah, it's like a
So
gate.
just go here. Then the moment it hits here, say, hey, don't go here, and then go here. So now at the end of the day, it almost acts like this guy, right?
All right,
And
guys.
we can lit our LED bulbs. Isn't that exciting?
Yep.
All right, I'm gonna give this to you guys.
It's a hands magic, by the way. So Mia, I think that's a great part.
All right, guys, I'm gonna give this to you, all the props, and then you have to explain to us how an LED bulb works.
Okay.
Anybody wants to go first?
I want to see it.
All right. Pari, you wanna go first?
Yeah.
Okay.
When these two bump into each other,
We can do it
Okay.
here, yes.
Yeah.
when
Bump into each other, yeah.
bump into each other,
Yeah,
then-
wait for
then-
your turn,
then
please.
They two like make the light go on.
Mm-hmm. That's
Beautiful
good.
point,
That's
beautiful
good.
point.
Ishita, you wanna explain as well?
Okay, so the electricity goes through here.
Okay.
Then this sends it to these two wires.
Okay.
Then it goes through the circuit board.
Mhm.
Then it goes through this diode.
Mm-hmm.
thing, and then it goes to the circuit board.
And then the diodes emit electricity using the principle that Pari just explained.
Yes, and then like
And by the way, this is not that principle that runs the school.
and
All of you are doing an amazing job. Keep creating beautiful little engineers, by the way.
yes, and then these two collide together,
Make us
and then
all
it generates heat.
Yes,
Yes.
there you go. Mia, you want to explain too?
beautiful.
All right, go for it.
This sends electricity to the circuit board and it's connected. So it goes into the circuit
And
then it goes to the red one connects to here and the black one connects to there.
okay,
And this is actually not a part of the circuit, but it's just to hold something.
okay,
See?
okay. And
But the black wire goes into the circuit board
okay,
and then it goes to this, the
Okay.
resistor.
okay,
And it slows down
okay,
the electricity.
okay,
And then this one goes to the there.
okay. And then what happens?
And then they mix up.
Okay.
And then they mix up.
Okay.
And then they go to the circuit board.
Yep. They mix up using the relay, and then what happens?
And then they go to
Capacitor.
the capacitor.
Okay.
And then the capacitor takes it to this.
Okay. What is that?
It just holds it the charge and then it
Okay.
makes it go to the diode station.
Okay.
And then it goes through all the diodes.
Okay.
And then it comes to the circuit board. And it just is there now. Okay, done. I'm
Okay.
done.
And then diodes send the electricity. You want to, and then like Pari and Ishita already explained, when positives and negatives come together like this, they emit the light using diodes.
I love the diode station. I mean, that's a very creative.
That's a creative
That's a
plan.
very good job.
Yeah, like the diode train station.
So,
Yeah.
All right, guys. So that was good
so
explanation.
that was, I think, so today we learned bunch of things. So we learned why we use LED, because we want to eat as many donuts as possible, right? And we want to change the color of the light, and
Yep.
LED can help us do that. And then we also learned there's electricity that goes inside the house is not what's in the battery, so we convert it using something called that's called driver. It drives electricity into something which the LED can use. And then, as Ankur uncle and all of you explained beautifully, when the holes and the electrons collide, they generate electricity, they generate light, and that light will lit up the room. And that is how LED works. And this is again this by the way, one more time I want to re-emphasize the security measure. It requires us to sort of twist open the bulb
Using a vise, so please use an adult. To do that.
using a vise. So yes, we have to use an adult and be very cautionful of what we are doing. So we'll start. Yes, Nia, quickly, what do you want to say?
Can we leave now?
We very soon. Ishita, do you want to say something?
What do diodes do again?
So diodes, okay. So diodes are like, it's like your classroom. So your classroom has all the boys and the girls, and whenever sort of your friends sort of run into each other, they produce light. That's what diode do. So it has holes and it has electrons. They work together in a sandwich. So it's like a sandwich. Yes, but not quick.
And remember
and you
Yes. So again, team, thank you so much for watching this video.